Oh, hi everyone. In this video, we are going to study antiderivatives. So we're gonna see how to find antiderivatives and what is an indefinite integral and what is an initial value problem. Okay, so let's first take a look at the definition of antiderivative. The definition says the function capital Fx is an antiderivative of function little fx if the derivative of capital Fx equals little fx. For example, since we know that the derivative of x squared is 2x, therefore, according to this definition, the an antiderivative of the function 2x is the function x squared. Now, an antiderivative can be thought as undoing a derivative. What does this mean? We know that to find the derivative, we need to differentiate the function. Like here, we can find the derivative of the function x squared by differentiating this function so we can get 2x, right? Now, if we're given the function 2x and we are asked to find the antiderivative of this function, this is like we want to think which function, when we take the derivative of that function, we can get 2x. So the answer will be x squared. Now, another interesting fact about the antiderivative is the antiderivative is not unique. This is different as the derivative because the derivative is unique. Like the derivative of x squared, it just be 2x, right? It can be 3x or 4x. But the antiderivative is not unique. Any given function has multiple antiderivatives. Like why? Because say the derivative of x squared is 2x, so the antiderivative of 2x is x squared, right? And also, since the derivative of x squared plus 1 is also 2x, right? Because when we take the derivative of this function, we got 2x, and the derivative of the 1 is 0. So we can also say that x squared plus 1 is an antiderivative of 2x. And similarly, x squared plus 6 is an antiderivative of 2x. So any function of this form, x squared plus constant, say it's a constant, will be an antiderivative of 2x. Because when we take the derivative of any function of this form, we can always get 2x. Okay, so now I would like you to think about this problem. Which of the following are also antiderivatives of the function 3x squared? Okay, so to do this problem, to solve this problem, we just want to look at which of the following functions, when we take the derivative to that function, the result is a 3x squared. If the result is a 3x squared, then according to the definition, that function is an antiderivative of 3x squared. Okay, let's start do this. So when I take the derivative of x to the third, I'll get 3x squared. So x to the third is an antiderivative. And when I take the derivative of x to the third minus 3 pi, I will get 3x squared minus the derivative of 3 pi is 0. Okay, so the second function is also an antiderivative of 3x squared. Now, when I take the derivative of 3x to the third, I'll get 9x squared, which is not equal to 3x squared, so c is not. And when I take the derivative of e to the 3x squared, so for this one, we are using chain rule. So the derivative is e to the 3x squared multiplied by the derivative of the inner function, which is 6x. Okay. So from the given options, only a and b are the antiderivative of 3x squared. Now, according to this, according to what we learned previously from here, we can see that we can write the form. We can write a general form of the antiderivative of the function 3x squared. So any function of this form, x to the third plus a constant, will be an antiderivative of 3x squared, right? So that's why x to the third minus 3 pi is also an antiderivative. So any function of this form, we call it the family of antiderivatives. So the definition of the family of antiderivatives is this: let capital Fx be an antiderivative of little fx. Then all the antiderivatives of little fx have the form capital Fx plus c, where c is a constant. Using this example, because we have seen that x to the third, this is our capital F x. X to the third is an antiderivative of the function 3x squared, because when we differentiate this function x to the third, the derivative is a 3x squared. So x to the third is an antiderivative of 3x squared. Then all the antiderivative of 3x squared have the form x to the third plus a constant. All right, now let's look at this problem. We want to determine whether the following statement is true or false. So it says if the derivative of a function little fx equals the derivative of function little gx, then fx will be equal to gx. Now, do you think is this true or false? Now, this is false. Why? Because say we have two functions. One is x squared plus 3, and the gx is x squared minus 4. Now, obviously, these two functions are different, right? However, when we consider their derivatives, the derivative of NATO fx is 2x, and the derivative of NATO gx is also 2x. Their derivatives are the same, right? But the functions are not the same. So why? Because for this function for 2x, the function 2x, the antiderivative of the function 2x is x squared plus a constant. Since x squared plus any constant is the derivative of the function 2x. So when we take the derivative of x squared plus c, we always get 2x, but because of c, the function can, like the antiderivatives can be many, like x squared plus 3 or x squared minus 4. Okay, so this statement is not true. Okay, now after we see what is an antiderivative, now let's take a look at what is the indefinite integral. The indefinite integral we write into this way. Okay, we use this symbol. Now this symbol is the symbol for integral. Okay. Now the notation stands for the family of antiderivatives of a function NATO fx. So in other words, when we are given this symbol, so what we are asked to, if we are given this symbol and ask what does this equal, so what we are asked to do is to determine what is the antiderivative of this function NATO fx, and then we plus c, so we can find the family of the antiderivative of this function NATO fx. So the indefinite integral gave us the antiderivative, gave us the family of antiderivatives of this function NATO fx. So use our previous example, since the family of the antiderivative of function 3x squared is x to the third plus a constant. Therefore, the integral of 3x squared dx, this will be x to the third plus c. So here 3x squared is our NATO fx, and x to the third is our capital Fx, because the derivative of capital Fx equals NATO fx. Okay, now let's see another example. Here we have the integral of sine x dx, and we want to find what this is. So the little fx is sine x. Now we want to find what is capital Fx. So this is like, we want to think which function capital Fx. When we differentiate this function, the result is a sine x. So if we recall the formula of derivatives, we know that when negative cosine x, when we take the derivative of negative cosine x, the result is sine x, right? Therefore, the capital Fx is a negative cosine x. So the family of antiderivative of sine x we can write as the capital F plus a constant. So that will be the answer. Right. Okay, in the next video, we will look at some basic antiderivative rules. And using those rules for some functions, we will be able to know what is the antiderivative quickly.